You. So yesterday, as the topic was given to me, was the AI for the cloud computing, and in the yesterday we just try to cover the challenges and the solutions and the benefits which are brought in by the artificial intelligence, and how the AI is emerging as one of the key solutions for the cloud computing services, and how the AI based solutions are being applied at different stages. So, today, in order to proceed further, I will just take it down to the next stage. So, today I will be just focusing on specifically on machine learning models. So today I decided to just took a topic as leveraging the machine learning models to transform cloud computing challenges, solutions, and benefits. So these are basically the idea regarding today's talk. So as far as this particular topic is related to machine learning models for cloud computing, I will just try to cover up these particular potential key points, and if the time allow, yesterday also I took one case study where the integration of edge, cloud, and AI for the Internet of Medical Things. Uh, I thought to just discuss this case study. So I will see if the time allow, we can just have a discussion on this case study as well. And initially, I will just try to cover up what machine learning brings in for the cloud computing applications. Then we will see what are the current challenges and what challenges machine learning model faces while we want to implement in the cloud computing. Then we will look for the machine learning based solutions to overcome the cloud computing challenges. And then I thought, let's identify the few key machine learning algorithms that are being applied. And thereafter, I took another part where it is on envisioning the future of machine learning model for ML supported cloud computing. Here we will see how the latest technologies like deep learning and other technologies are evolving, like federated learning, and how this is being applied for various applications of cloud computing. Before that, I thought, let's identify few benefits, and at the same time let's compare the downside as well. So I will be touch upon the benefits of bringing the machine learning models in cloud computing, and then afterwards we can have some discussion on what are indirect challenges or the downside of applying the machine learning models to cloud computing. And then we will see what is the current status in context to the machine learning model and cloud synergy. So this is how I thought I have to begin with the outline of this today's talk. So in the first part, I would try to cover up the introduction on the machine learning models and cloud computing. Before I proceed, for better connectivity, let me switch off my video first. Just a minute. I hope you're able to see my slide.
Yes, sir.
Okay, thank you. So as I was talking about, let's first identify the
Yes, sir.
key machine learning models which are commonly used. So if you go back and search on the Google Scholar, you will find a lot of papers on the first, or I would say the basic machine learning model, which is based on the linear regression model. So in this particular case, as we know that this linear regression models is based on the dependability. So in that case, we have applied the same statistical method to model the relationship between a dependent variable and one or more independent variable. So it assumes the linear relationship between the two variables, and the same concept is being deployed for the cloud, where the linear regression is applied for handling the task request. So that Linear regression can be useful in cloud computing for tasks like predictive analytics, resource allocations, and the optimization of cloud resources. Although the people have applied the other algorithms as far as the task allocation and the predictive analytics is considered, and there are few papers where the comparison is also being carried out between the linear regression and other models. As far as if we want to have an example, so with the help of that linear regression model, we can predict, for example, the future demand of cloud resources based on the historical usage data. And as far as the case study is concerned, I would say the Amazon is using the same linear regression model, and that already been implemented. But there are a lot of people who have carried out and do the comparison, and in that particular case, they just try to implement the comparison between the linear regression models. And nowadays we are using a deep learning as well. So you will see with the help of deep learning, they are the, of course, the better results, but that also belongs from the category of service as well, because the deep learning is more trained in context to accessing the image data. So initially, I would say that if we want to predict the demand for the EC2 instances, that particularly the linear regression model was one of the good fit. Another model which is also being implemented, and that is also part of machine learning model, that also been incorporated in the cloud computing services, is random forest. So in this particular case, as far as the random forest work on building the multiple decision trees and merge their predictions to improve the accuracy. And the best part with this model is it can reduce the overfitting. So as far as it can reduce the overfitting, if we see the utility of this model for the cloud, the random forest model can be applied in cloud computing for tasks like anomaly detection, fraud detection, and the recommendation systems. So as far as the applications like anomaly detection and the fraud detection is concerned, this random forest could be one of the best way where it found to be very effective. And if we look at the example, the detecting anomalies in user behavior to predict the unauthorized access to the cloud services. And as far as these particular services is concerned, nowadays there are a lot of companies who have implemented these services in the automatic mode as well. Probably, if you will see, I can just give you an example. Let's suppose if you're using a credit card, and usually, if usually the because the credit card company have already your history or your past data, and they know what are the instances where you actually use your card. So if for let's suppose 90% of time in the Indian standard time we use, for example, say between 8 a.m. to 10 p.m. And if you are trying to use a credit card at 3 a.m. in the morning, then of course this is a different kind of pattern. So if there is any pattern which is not meeting up with the past records, so in that particular case, this could be considered as an anomaly. So if this is an anomalies in the user behavior, there could be a chances someone else is trying to use your credit card on your behalf. So of course, we get sometime a random call, and the company would like to have an authentication or confirmation that whether this transaction are being tried by you or by somebody else. So this is how this automated system are being set up. So, for example, if we were to see at the case study, the Microsoft Azure utilizes a random forest model for anomaly detection in its Azure Security Center, and helping to identify and respond to the potential security threats in the real-time system. So this particular model is one of the important model. Another one which is, I would say, that is the base for the deep learning models is neural network, because all deep learning model are being evolved through the neural network models. And to further improve the efficiency of this particular model, this deep learning studies are being conducted. So as far as this neural network model is concerned, this follow a set of algorithm, and here in this particular case, the model loosely after the human brain and that are designed to recognize a pattern. And as we all know that we have the million of neurons in our brain, and these neurons are being interconnected. So in the similar way, the each node is to be considered as a neuron, and they are interconnected with each other to do interpretation of the data which is being feed in. And based on the feed in, this particular neural network are being trained to adjust the weight to get the better results. So this is how there are a lot of trained model which are already in place and that are being used in the cloud computing services. As far as the useless or usefulness for the cloud is concerned, these particular network models, which are neural network based model, these are highly versatile and it can be used for various tasks in cloud computing. For example, the image recognition is one of the area which require a lot of data processing, and neural network are the best fit. And as I said a few minutes ago already, there are a lot of studies where the people have compared the computational time and efficiency of the neural network and it found to be very effective. And further, in order to improve it, there are a lot of deep learning model which are coming up where the efficiency is quite better as far as the image recognition is concerned. The another could be, I would say, including image recognition, the natural language processing is another part or another set of application, and the other could be a time series forecasting. Apart from that, if you would like to see, for example, an sample for it, there could be a possibility if, let's suppose, we want to classify the images uploaded to a cloud storage service. So if you want to classify the images, the best way to classify with already a trained model is neural network. So as far as this example is concerned, the Google Cloud Platform, which is GCP, offer various neural network models through its API platform and allowing developers to build and deploy the custom machine learning solutions in the cloud. So this is how this particular learning model is being applied for various applications, and it is already in use. The another one which is very popular and that has also been implemented in specifically in the cyber frauds or in the intrusion detection is support vector machines. So again, the SPM, we all know that these are basically the supervised learning models. So these supervised learning models are being associated in the cloud computing. And here the whole idea is to analyze the data for classification and regression analysis. So we can identify easily the regression coefficient value, and the data could be classified into several parts. As far as the usefulness of support vector machine in the cloud is concerned, this support vector machine are useful in cloud computing for the task like text classifications, sentiment analysis, and intrusion detection. So let's suppose you want to build a cloud-based model where you want to investigate or you want to analyze the sentiments on a specific trends. So that is one of the best way we can apply the support vector machine, and the sentiment could be analyzed in a specific scenario. Apart from that, if you look at the example, we would say the classifying the customer review a product or a service hosted on a cloud-based e-platform is one of the best example. So let's see if you buy a product from the Amazon. At the same time, you can see the lot of customer reviews. So there would be some customers who have rated the product as 4 or 5 or 3 and 4. So according to that rating, we can classify the customer reviews of the product or services on any the cloud-based platforms, specifically for the e-commerce application. So this is one of the best application where it is applied. So this is one example. So and as far as the utility is concerned, the IBM cloud has leverages the SBM model for the intrusion detection as well, and for the prevention. And this model also helping to secure the cloud infrastructure, and it may also protect against the cyber threats. So this is one of the most powerful model as far as the classification and the regression analysis is concerned. The another model which is very popular and that is being used for the resource allocation. So, and that particular case, I would say the machine learning algorithms can analyze the historical usage patterns, and that can predict the demands of the future. So once they are able to predict the demand of features, I think I would say this enable the cloud providers to dynamically allocate resources and optimize the performance and cost effectiveness. So, as far as the example is concerned, the Amazon EC2 utilization of machine learning models to predict the demand for computer instances, allowing for productive provisioning and efficient resource utilization is one of the example. If you would like to correlate this optimized resource allocation specific to a cloud application, I would say the AWS use of ML algorithms resulted in a 25% improvement in resource utilization and 30% reduction in the cost for EC2 instances. And there are a lot of research which is being conducted in order to identify what percentage of improvement can be carried out in context to the resource utilization and the reduction in the cost. And there are a lot of models which are coming up and where the efficiency in term of resource utilization have been improved beyond 25% as well, and the cost is being reduced more than 30% as well. So this is one of the way where the optimized models are quite popular. Then other one could be automated scaling and provisioning. So if we would like to see and understand how the machine learning models are transforming cloud computing in different ways. So in the first instance I talked about the resource allocation. The another way to apply these machine learning model and transforming the cloud computing services would be the automated scaling and provisioning. So as far as the automated scaling and provisioning is concerned, the machine learning model can automate the process of scaling cloud resources up or down based on real time demand. So this is one of the best part. So there is no need to manually scale up or scale down the requirements, but these models can set up according to the if the demand is high for, let's suppose, for a the website as I was discussing about yesterday, for example the Black Friday sales. So if there is a lot of resources which is required to provide the good response time to the clients, and if a load is increasing continuously, then the requirement of resources could be up, and if it is not required on Monday, then this could be scheduled to be down. So this is how the demand of real time demand could be meet out, and this helps in ensuring the optimal performance while minimizing the cost. If we just want to have an example of the concept, I would say that the Google Cloud auto scaling feature, which uses a machine learning algorithm to analyze traffic pattern and automatically adjust the number of virtual machine instances in response to changes in demand, is one of the best example. And as far as the case study is concerned, we can consider the Spotify application, which is very popular for listening the songs. So the Spotify leverages the Google Cloud auto scaling feature to handle the unpredictable spikes in the user traffic during the events like album release or the concerts. And probably we all know that if a new album is being released, there are a lot of people who notice on the new album. So there could be a peak time or the spike in the user traffic which is coming to access that particular album, and slowly that spike get reduced, and then the demand is usually it's averaged, and slowly that keep reducing or maintain a minimum level. So this is how the Spotify is also leveraging the Google Cloud auto scaling feature to handle the unpredictable spike, and it ensure a seamless streaming experience for the users while minimizing the infrastructure cost. Because there was a big challenge for the companies like Spotify, because they cannot manually adjust the demand, because the sometime when the demand or spike goes up, they cannot allow a person to sit and analyze it, because if a user traffic is increasing at the same time, the requirement of the resources should goes up. So that is being automatically scaling, and this is how the Google Cloud is providing this service to the Spotify. The another way the ML is transforming the cloud computing is it is helping in enhance the security and the threat detection. So as far as the explanation in context to security and threat detection is concerned, these machine learning models are quite proactive, and this can identify the potential threats at very early stage. So that is the advantage with these enhanced security and threat detection models. So I would say, because these particular models can analyze the vast amount of data to identify the patterns and the anomalies, and this enabling more effective threat detection and proactive security measures in the cloud. As far as the example is concerned, I would quote upon the Microsoft Azure Security Center use of ML to analyze the network traffic, and it can detect the suspicious activities which are indicative of potential cyber threats. As far as the case study is concerned, I would say by leveraging the Azure Security Center machine learning capabilities, the payment processing companies like Square improved its ability to detect and respond to the security incidents. And if these particular incidences can be reported well in time, this lapses can easily be handled. So this can reduce uh, the time in identifying and mitigating the threats from week to hours. So if we can mitigate those threats and we can overcome from those threats in spite of weeks to hours, this keep building a trust among the users, that the users feel that we can keep using these services and these particular databases are secure. So I think this is another example where the enhanced security and threats is another way where the machine learning models are applied in cloud computing. The another one is the personalized recommendation and content delivery. So, as far as this personalized recommendations and content delivery is concerned, yesterday also I have given some examples, and all channels like Netflix are using the same concepts of machine learning models. So, what they usually do is they try to analyze your past behavior. For example, once you install the system and it asks for your data. For example, what is your preferred language? Like, let's suppose you select English, then it will ask you what kind of serial or the movies you look like. So if you want the action movie, or maybe a romantic movie, or any other kind of movie, so this is how it is trying to understand your behavior, and then it adjusts your preferences, and based on your preferences, the kind of serials or the movies or the TV channels you visit, this keep on trained by machine learning training using machine learning models, and thereafter some period of time it start providing you the recommendations that this is a new serial which is an action serial or an action movie. So probably if it is pop up at your window, there would be chances that you might subscribe to that particular movie or a specific serial. So this is how this provide the better user experience and better satisfactions to the user. So the machine learning model are found to be very effective as far as the personalized recommendation and the content delivery is concerned. So the Netflix, I would say, is one of the recommendation system. Although the all channels like, if let's suppose you say apart from the Netflix, you go to any channel that is also using the same kind of concept. By the whether it's Airtel or whether it's Geo or other service providers. So in the similar way, I just took the most popular one, which start using it. So the Netflix adoption of machine learning driven recommendation system has significantly contributed. Uh, so this is how this Netflix is trying to uh, put best efforts for the user engagement and the user retention. And sometime whenever we want to unsubscribe these particular channels, that start offering few offers to the user, so they keep on engage with the channel services. So this is how they try to understand the user behavior and provide the best plans so the user can still retain. And this is how with personalized recommendations accounting for a significant portion of content consumption on the TV channels or on uh, the channel platforms. The another way I would say where the machine learning models are transforming cloud computing is the predictive maintenance and optimization. As far as this predictive maintenance is concerned, in this particular case, the machine learning model can analyze the sensor data from the cloud connected devices to predict the equipment failure and maintenance need. And that can also enabling proactive maintenance and optimizing the operational efficiencies. So normally what happen in the industries, they are initially there were some schedules, and at that particular schedules the predictive maintenance were usually carried out. But these machine learning models can analyze it in a better way. So if we look at the example, the General Electric predict platform leverages machine learning model to analyze the sensor data from the industrial equipment, and it can predict the maintenance need to minimize the downtime and optimize the performance. That even the understanding of the downtime and optimizing the performance is more contextual to the banking application also. And whenever the bank also do the proactive maintenance, we always got a message that this is a downtime for the bank, and usually it is in Indian standard time at the during the time of night. So there would be minimum number of customers which get affected due to the downtime. And if we would like to see a case study by implementing this predicts platform for the predictive maintenance capabilities, wind turbine manufacturer Vesta reduced the downtime by 50%, and it increased the reliability of its wind turbine, resulting in significant cost and improved customer satisfaction. So, this is a significant advantage of applying these machine learning models in the General Electrics. And in the similar way, there are studies where the people have applied in different industries, and they have reduced the downtime, and at the same time they improve the reliability and improve the save the cost as well. Apart from it, let's try to look at if we want to implement the machine learning model, what are the present challenges? So let's have some discussion on the challenges as far as the implementation of these models is concerned. So the first and the foremost challenge which initially strike to our mind is the data security and the privacy concerns. So, as far as the storing and the processing sensitive data in the cloud is concerned, it raises a lot of concerns about whether our data would be secure or not. What about the privacy? And usually, the next uh, point which comes to the mind of common people is, if we are providing our data to the third party, how the third party will use its cloud services. So in order to handle it, there are some ethical guidelines and there are the regulations also which are being imposed on these companies. And even I would be happy to share with all of you that probably some of you might be aware of the data protection bill has already been passed by the government of India, and this is the act now. So this is a key responsibility of the cloud service providers to keep the data secure and also maintain the privacy of the customers. So, if the data is being shared with the company, this is a responsibility of the company to keep this data to be secure, and it should not leak from the company server. As far as the organizations are concerned, the organization must ensure that the data is encrypted and the access control are well in place and the compliance requirements are met to protect against the unauthorized access and the data breaches. So this is how the data could be secure. And as far as the example is concerned, I thought let's take an example from the healthcare. So the healthcare organizations are using the patient data. So if all patient data records are being in digital form, this is a responsibility of the healthcare organizations to keep this data to be strictly with themselves. And if this record is being publicly disclosed, this could somehow tarnish the individual reputation, and sometimes this could be a big mess because if this would be a public information, uh, the entire actual status of a particular city or a country could be in the public platform. And so this is how the strict regulations are being imposed, and these particular health organizations are not supposed to share this particular data with anyone which is not authorized or have an access to that particular data. And this is how it requires the robust security measures to safeguard the patient data. If we want to just have a reference to this particular case, in 2018 the healthcare providers in Athens suffered a data breach, and in that particular case this Athens suffered a data breach exposing the personal information of around 78 million individuals due to inadequate security measures. So this incident underscores the importance of robust security practices when handling sensitive data in the cloud. So this is not very old case; it just had 5 years ago. So in that particular context, this is the challenge the company should take care in mind. They should have a proper system in place where the best security measures are being applied. Another challenge while implementing the machine learning models and in the cloud computing is about the scalability and the performance. So, as far as the scalability and the performance is concerned, scaling machine learning models and the cloud to handle the large volume of data and growing user demands require the careful optimization of resources and infrastructure, because This is the duty of the companies uh, for ensuring the consistent performance and responsiveness while scaling can be challenging, particularly for a real-time application. But we have seen the different success stories, and there are a lot of e-commerce platforms which are using this automated scaling facilities, which is being leveraged by applying the machine learning model in the cloud. And e-commerce are the best platforms which are the example. But still, in that particular case, there is a need to understand how this algorithm dynamically maintain the responsiveness and deliver the personalized experiences to the user. And as far as the case study is concerned, I would like to just share with all of you that Alibaba cloud infrastructure handle billion of transactions and requiring advanced scalability and performance optimization techniques to support the surge in the traffic and deliver a seamless shopping experience to million of the users. The another challenge uh, while implementing these machine learning models in the cloud computing includes the model deployment and management. So, if we want to deploy a model, what could be the strategy for the deployment and how to manage these particular services? So, the deploying and managing machine learning model in the cloud involves the challenges such as version control, model monitoring, and integration with the existing systems. And as far as the organizations are concerned, the organizations must establish robust DevOps practices and the deployment pipeline to automate the deployment and management of models effectively. As far as the examples are concerned, I would say this is more contextual and related to the financial services companies or the banking services. So, a financial services company deploying a ML model for fraud detection needs to monitor the model performance because they can't take a risk. And if a model is automated and it's working well, it is fine, but if there are errors in the model, there could be a severe financial losses. So this is a responsibility with the company that there has to be proper monitoring, and thereafter, if the updates are required, it has to update it with the new data and ensure seamless integration with their transaction processing systems. As far as the uses of this model deployment and the management is concerned, people employ the sophisticated machine learning platform called ML Engine to deploy and manage the thousands of machine learning model for fault detection and the risk assessment and the customer support. And the PayPal is one of the platform which is very popular for cross-country transactions. If you want to send money outside India or to any country, this PayPal is a platform where you can just create your account and you can just charge your wallet and you can transfer the fund or pay the money and with certain restrictions, because in India also the Indian government has imposed some restrictions on the PayPal. Before a person access a PayPal, they have to complete the KYC. So after completing the KYCs, when the PayPal guidelines are accepted by the customer, you can do certain transactions. So this is one of the company which have incorporated the ML based models, and this ML engine provide features for versioning, monitoring, and scaling model in production environments and enabling people to detect and prevent fraudulent activities effectively. If somebody is who's trying to send the money and which found to be suspicious, these models, I have done some analysis, and this is how the PayPal is being incorporated this machine learning model. But still there are a lot of challenges and still it requires a lot of data. So sometimes we all know that the restrictions with the machine learning model is the data. So if we have a limited data of past, these models require a lot of training and a lot of data. So if more the data we have, the more the chances the training would be better, and the trained model would work better in terms of the efficiency. The another the challenge which comes into is about the running machine learning workloads in the cloud can occur a significant cost, specifically when utilizing high performance computing resources or large scale data processing services. So the organization need to optimize the resource utilization, implement the cost monitoring tools, and leverage the cost effective pricing options to manage cloud cost effectively. And as far as the examples are concerned, a startup developing a machine learning driven products need to balance the computational requirement of a training model with the available budget to avoid the overspending. Hello. Yeah. So as I was talking about the another challenges in this particular case, there are some challenges in context to reducing the cost and managing the workload. Apart from that, another key issue, which is in context to utilizing the machine learning models, is concerned that we have already discussed in context to data security and privacy. So scalability and performance, this can also be in context to the Apache Spark and the TensorFlow, where it utilizes the distributed computing framework to parallelize the model training and interference across the multiple nodes. So enabling scalable and high performance machine pipelines could be a solution. And the example is the Airbnb, which is very popular website and the platform leverages the Apache Spark for distributed data processing and the model training, and that is being utilized for enabling them to scale their machine learning pipelines to process massive volume of user generated data and deliver the personalized recommendations to the million of users in the real time. The biggest advantage with this particular model says, because if we just look at the traffic of users which is coming up on the Airbnb website, this is one of the best website in the Europe and as well as in US also for booking the accommodations. So there are a lot of people who used to book their particular accommodation requirements through this particular website. So there's a lot of traffic is coming on this particular website. Sometime we want to compare the available uh, options, and accordingly we want to put some restrictions, or you want to have a personalized experience in context to you want a room, let's suppose in a dollar, I would say between 20 to $30, and there's a specific location also, and you are looking at other restrictions and other features. So this is how it can deliver personalized recommendations to the user in the real time. This is one of the best example where the machine learning models is being incorporated in the cloud computing. The another example or the key solutions which is already utilizing the ML model is the Netflix. And so this we have already discussed, and this is already being providing this services across the globe, is not limited to a specific area. So apart from that, the another solutions is where the cost management is being handled, and this is through, for example, through the Google Cloud API. And the Google Cloud API platform provides built-in auto-scaling capabilities that automatically adjust the number of compute instances based on workload, demand, enabling organizations to optimize the cost while ensuring consistent performance for machine learning workloads. So these are the key algorithm, and where I just tried to list out the example. So this is these particular models I have already discussed with you. Initially, we begin with the linear regression, and then we discuss about the random forest, neural network, SVM. This is another one which is the clustering algorithms, or for example, the k-means algorithm. As far as the clustering algorithms are concerned, the clustering algorithms are used in cloud computing for tasks such as customer segmentations. You want to group the resources in a particular based on their interest or their similarities. So this algorithm is very useful. In the similar way, the anomaly detection and enabling organizations to gain insight from large data set and optimize operations is possible through these machine learning algorithm, and that is the one which is clustering algorithm. And the Alibaba Cloud utilized this k-means clustering for customer segmentation, grouping user based on the similar behavior, their preferences, and it tried to provide the personalized services and improve the user experience on its e-commerce platform. The another one which I initially I just put emphasis on the improved version of neural network, which is your deep neural network or the convolution neural network. In this particular case, the particularly the convolution neural network are widely used in cloud computing for the tasks such as image recognition, object detection, and the video analysis, and enabling advanced multimedia processing and content understanding. So as far as sometime the security is concerned, we have the continuous video stream data. This is the best model to analyze the frames, and that can easily be detect the different objects. So this is one of the best way where we can have this data on the cloud, and this is being easily analyzed through the deep learning models. Although the computational efficiency of these models are high, but that require a lot of resources at the same time. So the Amazon Recognition, a cloud-based image analysis service, employs CNN to recognize object scenes and faces in images and videos, providing developers with powerful tool for building intelligent applications and services. So I just try to list out these particular machine learning models so we can have an listing. So the first one was a linear regression, and if we would like to connect with the service which is available is for the Amazon EC2, and the benefit was based on the historical data. This model can optimize the resource allocation and the capacity planning. The another one which I have discussed was the random forest, and this is in context to Microsoft Azure Security Center. And I just touch upon this is one of the best model for the anomaly detection in the network traffic, and this is how it's improved the security by identifying the potential security threats such as intrusion and suspicious activities. The other two models which I have also discussed was the neural network and support vector machine. As far as the neural network is concerned, this is in context to Google Cloud AI platforms where enabling various applications such as image classification, natural language processing, time series forecasting, allowing for advanced analytics and personalized services. And these services are further being improved through the deep learning or deep convolution neural network. The support vector machines, the concept is already being explained in context to IBM Cloud, where the IBM Cloud has incorporated the SPM for intrusion detection and prevention by analyzing the network traffic patterns and enhancing the cloud security by identifying and mitigating the potential cyber threats. The another one is basically the cloud algorithm, which is
Your voice is not audible, sir. Sorry for the interruption. The speaker may join within few seconds. Meanwhile, you all can just fill in the feedback form which is available in chat box, as well as there is a quiz wherein you have to complete it by today uh, at 11:59 p.m. today. By 11:59. Kindly fill the feedback. Thank you.
Am I audible now?
Yes, sir. You are
Yeah.
audible.
Let me share the screen again. Can somebody confirm me at which particular PPT I was while the connection get lost, so I can begin with that slide only?
So like about machine learning extraction and output.
Which one?
Machine learning techniques.
Okay. Probably I was there while I was discussing about the machine learning models, services, and the benefits, right?
Yes, sir.
Okay. So let's continue with how the deep learning models is being applied in the cloud computing, along with some examples. As far as the applicability of these deep learning models are concerned, these are found to be best useful for image recognition and the processing. And NLP is very popular in context to converting the unstructured text into the structured text. The predictive analytics and the recommendation systems are also one of the category where the deep learning algorithms are being applied. The medical imaging and the healthcare is another area where the cloud-based healthcare platforms utilizes the deep learning algorithms to analyze the medical imaging data. For example, if you have a lot of X-rays and you want to analyze what exactly we can conclude from different X-rays, so based on those X-rays, the deep learning based model can be trained, and similarly, this model can be applied on the MRI and the CT scans images, and for tasks like disease detection, tumor detection, and the treatment planning as well. So the deep learning model trained on large data set can assist the radiologist before they write their recommendations. They can just confirm with these models. So these could be an assisting tools to assist the radiologist, and it can also help the healthcare professionals in making the accurate diagnosis and the treatment decisions. And that was the reason I took the case study, which is in context to the uh, Internet of Medical Things. So as far as the applicability of deep learning algorithm in cloud is concerned, let's have a look at the steps which are involved in the deep learning model applicability in cloud computing. So the first and the most important step as far as the applicability of deep learning in cloud is concerned is first the data collection and the preparation. So in that, the initial step, this deep learning models are basically require the data, and data has to be pre-processed, and once the data is being pre-processed, that data required for training the deep learning model. So this may involve the cleaning of data, the formatting of the data, and augmenting the data to improve the model performance. Because as far as the formatting is concerned, there are a lot of issues when you want to deal with the data which belongs to different countries or geographical locations. Because let me share one example with you. Let's suppose you have a data which just talks about the date. So the date which is shown at my screen at the left bottom side is in the DDMMYYYY format. But there are few countries which follow the concept of DDMMYY. So in spite of, let's suppose we want to store the date, in that case it would be 26042024. But in the another format it may be 260424. So in that case, it's very challenging sometime to integrate the data. So the cleaning related to missing data, or you say the duplicate entries have to be handled. The data has to be formatted in the same format, and then we need to augmenting the data to improve the model performance. Once the data collection and the preparation is being carried out for the deep learning model, the next step which brings in is model training. So in that particular case, there is need to utilize the cloud-based machine learning platform or the framework. For example, let's say the TensorFlow, PyTorch, these are two which are very popular to train the deep learning model on the prepared data set. And this step involves selecting the appropriate architecture, defining the hyperparameters, and optimizing the model to achieve the desired performance. Once the model training is being done, the next step we can say at model evaluation. So there is a need to critically evaluate the trained model using the validation data set to assess its accuracy, precision, recall, and other performance matrices. And this step help identify any issue or the areas for the improvement in the model. Apart from that, we have to look at the another state which is called as model deployment. So as far as the deployment of the model is concerned, deploy the trained deep learning model to the cloud infrastructure using the containerization technologies, for example
Excuse me, sir.
Docker, Kubernetes.
Sir, I
Yes,
think the slides are not moving.
lights are not moving, but this is visible.
Can you please
I think
make full
I'm
screen,
at
please?
slide number 35.
Uh, we cannot see the complete slide, sir. Can you make it full screen?
Okay.
Okay, sir. Thank you.
I hope it is full screen now.
Yes, sir.
Yes, sir. Yes, sir.
Okay. So as I was talking about the next step in case of the deep learning applicability of deep learning model in the cloud is concerned, this is about the deployment of trained deep learning model to the cloud infrastructure, and then we can use the technologies like Docker or the Kubernetes or the cloud-based deployment services, for example, AWS, Lambda, or Google Cloud. So apart from these steps involve packaging the model into a deployable format and setting up the necessary infrastructures for the service predictions. So now there is need to see what about the scalability and the performance optimization. We have to monitor and maintenance, and thereafter there is a need to continuous improvement of the model, because as I said, these models are based on the data which is being feed into. So once we have the feedback how the model is performing, we can iterate on the deep learning model based on feedback and new data to continuously improve its accuracy and the relevance. And that may involve the retraining of the model periodically. So with the new updates and the data set, the slowly and slowly the model could be fine tuned and fine tune its parameter based on the user feedback. So this is how I just try to list out the benefits of applying the machine learning models in cloud computing. So if we look at the benefits of applying the machine learning model, the first and the most important, I would say, is the resource utilization or resource allocation. So the improved resource allocation could be one benefit, where the example is we can forecast the demand for compute instances to optimize resource allocation and the capacity planning. I just try to identify at least one company with respect to each benefit. So the Amazon is the company which is already being using it, and the service offered is Amazon EC2. The another one is the enhanced security, where the machine learning models are utilized to detect the anomaly in the network, and to identify the potential threats. One of the company which already being using is the Microsoft, and the service is Azure Security Center. As far as the another benefit which we already discussed was personalized recommendation, and one of the company which is using is Netflix, and the kind of service it is being offered is specifically the content recommendations. We already discussed about the predictive maintenance, which is already one of the benefit, and I token case from the General Electric, where the predicts platforms was one of the service. And as far as the real-time anomaly detection is concerned, the Google is offering the service which is Google Cloud Monitoring. The another benefit of applying the machine learning models could be the cost optimization, where the Spotify is one of the company which is trying to use this and trying to reduce its cost. So it just auto scale up its requirement or the resource requirement when there is a peak traffic at the time of, let's suppose, launching of a particular song or launching of an album. So the auto scaling with the Google Cloud Platform is the service which is being offered. The another benefit is advanced analytics, which is already being utilized by the company like Airbnb, and it is using the services of analytics with Apache Spark, and it's try to do the analytics in order to perform the complex analytics tasks like image recognition and time series forecasting. I just discussed about the company PayPal, which is using the ML engine on the Google Cloud for the seamless model deployment and the management. Alibaba is also an example where the high performance computing is being offered, and this offer the scalability and the flexibility, because that was a key demand, and the Alibaba cloud user base is very big. So if this demand could be meet out, uh, they just incorporated this high performance computing elastic concept. And in order to increase the efficiency and the automation, the company like IBM is using IBM cloud using the Watson AI platforms. So we have just seen the benefits. So I just try to cover up a lot of benefits of applying the machine learning model, and at the same time just look at what could be the challenges, or at the other side I would say what could be the downsides. So as far as the downsides is concerned, uh, the first and the foremost important is the data privacy and the security concerns. So that data privacy and the security concerns, I just try to look at one of the instances which have already occurred. So with the AWS S3 data breach is one of the example, and this was happened with the company Capital One, and in that particular case, the storing and the processing sensitive data in the cloud, uh, raising concerns about data privacy was an issue. So this is one of the example, and you can just search on the internet and you will find there are a lot of instances of the data breach. So there is still need to explain how we can handle the instances of data breach, and we can follow the compliances that vary from government to government and vary from country to country. So that is one of the challenge. The another challenge is the vendor lock-in and the dependency on the vendors or the service providers. So for say there is a company X which is providing a services, so the each company usually ask for that this services has to be utilized for a minimum period of time. So in that particular case, this is another challenge. The another challenge is the latency and the network performance, and that is more contextual. In context to the e-commerce websites, the complexity of the models, deployment, and the management in context to the small businesses is another challenge. And if we look at the transparency and the explainability part in context to the financial institutions, This is again the challenge in context to the compliances and the regulatory challenges, and the same is with the healthcare companies. So these are few points which I try to identify, which can explain the downsides of applying the machine learning models in context to the cloud computing. So, in the next part, let's see what are the future prospects of machine learning model and how this ML supported cloud computing can further utilize the latest technologies. So these are the few you say the case studies I thought I should uh, touch upon in order to see the possibilities of machine learning model in future. So as far as these companies are concerned, in order to explain the case studies, I try to identify the case studies from 14 15 companies, and along with that I try to list out the services. So the first name which came into mind when the keyword like cloud came in is the Amazon. So the Amazon cloud service providers is the company which is the most popular one. And as far as the ML services is concerned, the Amazon SageMaker, Amazon Recognition, these are the services which are very popular one, where the Amazon uses ML for product recommendations and image recognition. So by analyzing the user browsing and purchase history, the Amazon can recommend the products tailored to the individual preferences. And additionally, Amazon Recognition employ ML algorithm to analyze the images, enabling features like image search and facial recognition. And probably some of you have might also analyzed, let's suppose you just visit the website Amazon and you just search few product, and even if you do not purchase that product, next time when you visit the website you will find the similar kind of products which you purchased, which either you purchase or either you search in past few instances as in the recommendation. So you, what Amazon used to do is it keep on popping a data based on your past purchase patterns, that this could be a product which might attract you with the best price, with the one which is best choose to your preference in context to the cost, in context to the color. So they just try to analyze the user browsing history, and that browsing history uh, is being used to provide the customized experience. The another, if I would say in context to the Google, the Google is using the services as Google Cloud AI and also the TensorFlow. The example is Google applies ML for language translation and image analysis. The Google Translate utilize ML to improve the translation accuracy and language understanding. Moreover, the Google Photos employ the ML algorithm to categorize and search for the images based on content such as identifying the objects on the landmarks. The another the social media based service which is very popular is through the Facebook. So in that particular case, the Facebook is also using the Facebook AI, where the services which are being used uh, is about the PyTorch and the FBL learning flow. So in that case, what happened? The Facebook utilized the ML for content personalization and sentiment analysis. So in that particular case, the ML algorithm analyze the user interactions to personalize the content feeds, showing the relevant post and the advertise. Because sometimes you might have seen that if you search something on the Amazon and if you are using the same email ID to access your Facebook account, the similar kind of products keep popping up at your Facebook account also. So based on those personalized content feeds, they try to just keep on providing the advertisement or the relevant post information to the user. So additionally, the sentiment analysis model analyze user comments and the reactions to gauge audience sentiments toward post or toward the posts and the products. Now the Microsoft is also another company which have used and which is very popular through the Microsoft Azure platform, where they are using the Azure based machine learning services, and Microsoft apply the ML for predictive maintenance and natural language processing. So in that particular case, the Azure machine learning help to predict the equipment failures by analyzing the sensor data, enabling proactive maintenance, and reducing the downtime. So the Azure Cognitive Service offer NLP capabilities for application like chatbots, sentiment analysis, and the language understanding. Let's This is how this we already discussed upon. So the Netflix is providing the personalized content recommendation using the ML services. Yes, this is the another company which I thought let's look at as part of the case study is Uber. So the Uber uses the Google Cloud platform, and this uses the Google Cloud ML services. So this try to use the services like Uber employ the machine learning for dynamic pricing and route optimization, because sometime you might have also experienced if you land to a particular railway station or a particular airport, and if this is a peak hour, and if you want to go 10 kilometers, sometime for traveling to 10 kilometer cost you 300 rupees, while at another time traveling the same distance of 10 kilometer might cost you 150 or 180 rupees. So this is how this dynamic pricing is being implemented in the Uber itself, and they are trying to employ that machine learning for dynamic pricing and of course for the route optimization as well. So in that particular case, this particular machine learning model is already available in the real time, and this is basically providing uh, more profits to the company, and and finally we would say that the by understanding the traffic patterns, this generate more revenue and providing a better outcome to the company. And another one, as I thought to touch upon, is Airbnb. So that Airbnb is also using the AWS services, and AWS ML-based services are being utilized in the Airbnb for searching the and ranking. And apart from that, there are also the provision of identifying the fraud detection as well. So that machine learning algorithms improve search ranking by analyzing the user preferences and the property characteristics. And additionally, the ML model detect the fraudulent activities, enhancing trust and safety within the platform. So as I shared with you that you want to identify a particular property which you want to see to a nearest to a particular place, or and within a price range, or if you have other parameter also based on your preferences, this machine learning model keeps on providing you the best options. Now let's look at another sample where the tutor has also using the tutor cortex. So they have incorporated the concept of TensorFlow and the PyTorch. And the example is tutor apply the machine learning for content moderation and the personalized recommendations. So in that particular case, as far as the case of Twitter is concerned, the machine learning algorithms analyze the user generated contents to identify and mitigate abusive or harmful content. So normally, if let's suppose somebody is keep on writing the abusive sentences or the harmful contents, this can block a particular person. So these automatic blockage is being applied in the tutor itself through the machine learning algorithms. So moreover, the personalized recommendation system suggests the relevant tweets and accounts to user based on their interest and the interactions. So these are the facility which is also available in the Twitter. Now look at another service providers, which is a very big giant in cloud, which is Salesforce. So in that particular case, the Salesforce is using the Einstein AI service, where by utilizing this particular service, they have incorporated this machine learning algorithm for the sales forecasting and customer segmentation. So this ML algorithm analyze the sales data and the customer interactions to predict the future sales trends and identify the high value customer segments and enabling targeted marketing campaigns and personalized customer experience. So this is how these companies are utilizing this AI based cloud services. The another one which I would like to just touch upon is IBM. The IBM applied various ML services through the IBM Watson, and the IBM Watson based machine learning algorithm for the healthcare diagnosis and the financial fraud detections are very popular. So the IBM Watson analyzes medical records and diagnostic images to assist the healthcare professionals in diagnosing the disease and recommending the treatment plans. And moreover, the machine learning algorithms detect the patterns of fraudulent behavior in the financial transaction, which might reduce the losses due to these frauds. So this IBM is utilizing it for the financial institutions where they want the detection of the frauds, and at the same time, this IBM Watson recipes are being utilized in different healthcare diagnoses. So this is how these companies are implementing these particular machine learning algorithm. Now let's look at the utility of machine learning algorithm for the company like PayPal. So this PayPal is also using the AWS machine learning services where it utilizes the machine learning for fraud detection and risk assessment. So they are a person who's suspicious or whose uses is suspicious, or there are few transaction where it feels like the other suspicious transaction, it can block it. So they have incorporated the ML algorithms that can analyze the transactions data to identify the suspicious activities, and this is how it can prevent the fraudulent transaction. It provide a better security and the better trust in the platform. Now, this Netflix we have already discussed upon. This is another case that I would like to share with all of you. That is Snapchat. So the Snapchat is also using the Google Cloud machine learning services, where the Snapchat apply the machine learning for augmented reality filters and content recommendations. So in that particular case, this company is trying to use the machine learning capacities to power uh, augmented reality filters that can overlay virtual elements onto the user's real world surroundings, and additionally this provide a very high quality of recommendations. So this provide a personalized content recommendations, suggest relevant content to the user based on their interest and the interactions. So this is how we can say that there's more chances in the similar way. A lot of companies who will be using this machine learning algorithms in future, and the LinkedIn also using the machine learning algorithms where they are using the services of Azure machine learning or Azure cognitive services. So the machine learning services which are implemented by the LinkedIn is LinkedIn utilize the machine learning for the talent recommendation and skill assessment, because this is a platform which is considered to be the platform for professionals. So usually there are a lot of companies HR or the representative of the recruitment professionals are there who just sometime identify the best talents from the pool of people which are um, uh, matching to a particular profile. So in the similar way, the LinkedIn has made these jobs to be much easier, and the LinkedIn utilizes this machine learning algorithms for recommending the right talent, so they can recommend the talent recommendations. And at the same time, when the LinkedIn is recommending to the right talent, it can assess the skill set which is required for a particular job. So for the job seekers, and at the same time, if the job seeker has put their right skill set, this is more chances that they would be aligned to the right recruiters. So this is how this machine learning algorithms are analyzing the user profiles. And if a lot of job posting are there through the recruiters, then it keep analyzing those postings and the user interactions to recommend the relevant job opportunities and assess the user skills and expertise. And this is also facilitating the professional networking and the recruitment. So this is how the machine learning is incorporated in the LinkedIn. Another example, which as a part of which is already being used, is a case of Walmart. So Walmart is also using Azure machine learning platform. So in this particular case, uh, the Walmart apply the machine learning for demand forecasting and inventory optimization. So here in this particular case, I would say that ML algorithm analyze historical sales data, weather forecast, and other factors to predict the future demands for products and optimize the inventory labels, reducing stockouts and overstocking. So this is very interesting utility of machine learning, because if the big giants of the warehouses like Walmart can predict from its historical data or historical sales data that what would be the future demand. So if they can predict the demands, if they can understand what product they actually require, how they can ask for their supplier to increase the demand, and which set of products which are not in demand, there is no need to keep storing those products in the Walmart space. So this is how it can optimize its inventory label, and it can reducing the stock outs and overstocking problems. So this is how the Walmart has used the machine learning services intelligently. So this is how I just try to list out few companies which are using these services of machine learning. So this is a table which just have uh, and final list, where I just try to discuss the companies which are utilizing the ML supported cloud services. So I just discuss about the Amazon, Google, Facebook, how the Microsoft is also using through the Azure, and the Netflix for recommending the right choice of content, the Uber, how the Uber is doing the dynamic pricing and providing the best routes, how the Airbnbs providing the best search ranking and the fraud detection. At the same time, how the Twitter can do the content moderation, can block the users, can identify the relevant tweets, and recommend to the right set of users which map to your choice. And in the similar way, how the Salesforce is using the Salesforce Einstein AI service for the sales forecasting and the customer segmentation. Apart from that, I touched upon the utility of this machine learning models in context to IBM, PayPal, and Snapchat. So as far as IBM's Watson services are concerned, this is being incorporated for healthcare diagnosis and for the banking institutions, where its utility is being seen in the financial fraud detection. Apart from that, the PayPal is also using this AWS based machine learning services for identifying the fraud transactions and identifying the risk which are associated with with specific transaction which looks to be fraudulent. The Snapchat is also using the Google-based ML service for applying the AR filters, and in the similar way, it is using the Google Cloud ML for content recommendations. At the same time, I just discuss about the utility of machine learning models and context to LinkedIn and Walmart. So how the LinkedIn is using right talent recommendation and the skill assessments using the Azure machine learning or Azure cognitive services. Apart from it, as we discussed, the utility of this machine learning algorithms for the Walmart as well. So, where the demand forecasting and the inventory optimization is being incorporated through the Azure cognitive services and Azure ML model. So I just try to cover up few companies and the different utilities where the machine learning models are being incorporated. So apart from that, let's look at few evolving trends in machine learning for cloud computing. Because till now we just try to touched upon the already existing models which are already in place, and where the people have already seen its utility. But apart from that, there are few new models which are coming up, and there are a lot of research which is currently being carried out. So one of the most popular is the federated learning, and in this particular case, the applications could be the predictive text suggestions and the healthcare collaboration. While we want to implement this federated learning, I try to identify the challenges. So as far as the challenges is concerned, the data privacy is one of the challenge, and the communication overhead is also one of the challenge which they need to look upon. And as far as the future applications are concerned, I think the federated learning is best suited to the healthcare collaborative model training, where the patient data could be analyzed among the different doctors, and this could provide a collaborative platform for accessing the data to provide the best treatment. Apart from that, there is another technologies which is very popular, which is auto machine learning, and this could be used for predictive maintenance. And at the same time, I would say this is very popular in image recognition as well. So as far as the challenge is concerned, the lack of domain expertise, I would say, is one of the challenge, and the second one is interoperability of the automated models is another challenge. So, as far as the future applications in the cloud is concerned, I would say manufacturing is the one of the major application where it can democratizing the ML deployment for the productive maintenance. Apart from that, the quantum is one of the area which is also not related to the other application, but this could also be applied for the cloud computing. So the quantum based ML uh, may have also a lot of application, and specifically in the molecular simulation and in case of the optimization problem. But the challenge is the quantum machines limitation, quantum hardware limitation. The another one could be the error correction and the noise detection. But in the coming time, the quantum based machine learning could found to be very useful in the drug discovery, where we can identify very complex patterns with the help of quantum machine learning models. The other two technologies which I thought are very popular and which would have a lot of applications in the future are explainable AI and the edge computing based ML model. So as far as the explainable AI is concerned, the application of explainable AI could be in model monitoring or in bias detection. Where yesterday when we were talking about, let's suppose we implement this AI machine learning based models in analyzing the resumes. So if we are applying any machine learning algorithm to analyzing the resumes, and if there is any bias, then this could lead to the biasness in context to the race, in context to say a group of people or a person who belongs to a specific community. So in order to overcome these issues, the X level AI could be one of the solution in future, where the challenge is about the interpretability and the transparency, and of course the performance trade-off has to be seen. As far as the future application is concerned, I would say this could have the best application in the finance and at the same time in the healthcare industry as well, where it require and it can have a better patient outcome explanations. And the next evolving trends which I found from identifying a lot of papers through the Google Scholar is edge computing for machine learning, where this found to be have a lot of applications in the real time analytics, and at the same time the people have applied the artificial intelligence at the edge of the network. So, but the challenge is in the first case, I would say the challenges could be the resource constraint and the security and privacy concern. And the utility could be in autonomous vehicles where the low latency inference is there. And for making the real time decision, this could also be very useful. So, as far as this evolving technologies concept are concerned, let's have a small discussion on these particular technologies. So, as far as the first point which came into mind is the federated learning. So, the concept of federative learning allow the machine learning to be trained across multiple decentralized edges. So here in this particular case, this machine learning is being trained through the multiple decentralized edge devices or the servers while keeping the data localized and addressing the privacy concerns and reducing the need for data centralization, because there are a lot of issues if we want to put the data at a centralized place. So that similar concept is being utilized in the federated learning. And here, if we would like to see the example, the Google Gboard uses the federated learning to improve its predictive text suggestions without compromising user privacy. And the model in that particular case, the model is trained locally on the user devices, and only aggregate updates are sent to the central server. So in the future, that federated learning can be applied in healthcare for the collaborative model training on patient data, and that can also provide different facilities for specifically the medical institutions while preserving the data privacy locally at their storage. Apart from that, the another popular evolving technologies which I thought let's have a small discussion on it is auto machine learning model. So in that particular case, the concept of auto ML automate the process of designing, training, and deploying the machine learning model, and democratizing the machine learning development and reducing the barrier to entry for the non-experts. So as far as the example is concerned, I would say that the Google Auto ML provide tools and APIs for automating tasks such as hyperparameter tuning, feature selection, and the model architecture search, and that enable the developers to build the machine learning models with the minimal manual intervention. And in the future we can see there could be auto AML that can utilize in industries such as the manufacturing industries for doing the predictive maintenance, where the domain expert can easily develop and deploy the ML models without extensive ML expertise. So this is how we can see its uses in manufacturing industry, and there are few papers if you will search on auto ML, you will see its utility in industry 5.0. The another area which I thought I should just have a part of discussion is quantum machine learning models. As far as this quantum machine learning models are concerned, The concept of quantum machine learning model is to explore the intersection of quantum computing and the machine learning, and it is just trying to leveraging the quantum computing algorithm to solve the complex optimization and pattern recognition problems more efficiently. And this could provide the best services specifically in the drug discovery, and of course in providing this more secure platform. So one of the example I thought I should include as part of the presentation is IBM Quantum Experience offer the cloud-based access to quantum computers and simulators, and it is enabling the researchers to experiment with the quantum algorithm for tasks like molecule simulation and optimization. The another future applications where the quantum machine holds potential for accelerating the machine learning task could be such as, for example, this could be the best utilized for large scale optimizations for, say, for the drug discovery and specifically in cryptography. And once the quantum computing technologies can mature, this could be one of the best utility for the healthcare services. So by applying the quantum machine learning models, we can make our data to be more secure, specifically the healthcare data. Of course, we can see its utility in the financial institutions for providing more security to the financial institutions' data as well. Apart from that, I just consider as part of the future technologies as explainable AI. So this explainable AI focuses on making the machine learning model interpretable and more transparent, and this enabling users to understand the reasoning behind model predictions and the decisions. So how if something is being recommended by the model, what is the reason behind it, how the predictions or decision are being made. So this is basically the concept behind the explainable AI, where the IBM Watson uses the open scale providers. IBM Watson open scale provides tools for monitoring and explaining machine learning predictions and allowing the users to interpret model behavior and detect the biases of inequalities. So this could have the best application, of course, in the finance and healthcare sector. I would say that the explainable AI can be crucial in domains like finance and healthcare, where the transparency and accountability are essential for regulatory compliances and the user trust. And this I thought could be another utility where the edge computing for the ML, there are a lot of papers, and this is probably more contextual to the uh, Internet of Medical Things healthcare services. Where the if you search on IOMT, you will find a lot of papers where the people have applied the edge-based computing machine learning models for developing a complete infrastructures for the healthcare service. So here the concept of the edge computing covers the edge computing brings the computation and data storage closer to the source of data generation and enabling real-time processing and reducing the latency for ML inference tasks. As far as the example are concerned, the NVIDIA EGX platform combines the GPUs to accelerate edge computing with machine learning capabilities, and this is enabling real-time analytics and AI application at the edge for industries like this is being utilized in retail sector. This is also being uh, seen its utility in healthcare and the transportation as well. So in the future, the edge computing for the machine learning can have an revolutionized application such as autonomous vehicles, where the low latency inference is critical for making split second decisions during the dynamic environments. So I just try to cover up the evolving trends of machine learning models in specifically in the cloud computing. So I just try to touch upon the basic trends, and these are the technologies which are very popular. Now let's have a small discussion on this case study where I just took this paper where I was talking about the complete architecture of Internet of Medical Things was taken into account, and the integration of edge, cloud, and AI was incorporated. So I just took this paper for a discussion as a case study. So as far as we have a limited time, so I thought let's discuss about the key findings of this particular paper as part of the case study is concerned. So this is how the group of authors have explained the architecture of this Internet of Medical Things. So, as far as this architecture is concerned, this complete architecture was categorized into three parts, or in I would say in three layers, and that initially begin with the perspectual layer, and then the next layer is network layer, and the next one is application. So as far as the first layer, which is the perpetual layer, is concerned, this was further categorized into two parts, and the first part cover the data access and the data acquisition. As far as the data acquisition is concerned, the data acquisition is best possible through the RFID tags. So in that particular case, the data acquisition is one of the layer, and the another part which I would say as part of the perspectual layer is the data access. So in that particular case, the responsibility of the data access sublayer is to use a variety of accessing methods to connect the data and analyze the data which is being collected, so the data acquisition. So for doing the data acquisition, the RFID tags are very popular. So this is the first part. At the base level, we try to analyze, let's say, a patient ECG. So in order to analyze the data, that EMG, EEG, and ECG signals can be transmitted through the RFID, and for the communication, they could be any technologies. So for, let's say, in order to connect the data with the network layer, we can use short distance data transmission technologies. So that in this particular architectures, the short data transmission technologies which are very popular, the key technologies are the Wi-Fi, Zigbee, and the Bluetooth is being shown. So this is how through a gateway this data can be passed to the network layer. The network layer again divide these services into two parts. So in that particular case, this particular network layer may have two sublayers, and that two sublayers are, the first one is responsible for the network transmission layer, and the next one is the service layer. So as far as the key role of service layer is concerned, the service layer mainly do the integration of heterogeneous networks and integration of data formats. So in this particular case, this data can be integrated through the heterogeneous network, and once this data is being processed, this could be passed to the application layer, which have further divided into two parts as far as this architecture is concerned. And in this two-tier architecture at the layer of application layer, the application layer may have the medical information application and the medical information decision making application. So first, in the first part, we have the complete information related to the medical information is concerned, and thereafter, based on the available medical information, medical decision making application is considered to be the sub layer at application. So in that particular case, I would say this particular infrastructure, which is being divided into three parts, could be found to be very useful, and the application of medical information decision making can have very good patient information analysis, and this can identify the disease information and this would have a medical information analysis in context to diagnostic and other features. So this is how the complete architecture of IOMT is being discussed. And as we were talking about the edge, the utility of edge computing could have seen in the medical field. So this is one of the architecture which discuss about its utility. So we can just skip this particular slide and let's have a small discussion on the architecture part. So as far as this architecture is concerned, in this architecture is divided in context to in the between. You can see the cloud data centers are there, and this cloud data centers are being connected through the medical institutions, and they are the community clinics which can also fetch in the data to the data cloud centers. And at the bottom of our patients is being shown, and the disease control centers are being also shown. So in that case, this data cloud centers are connected with the MS, and so this MS is basically the monitoring systems, and MF is basically representing here the management functions. So in that particular case, at the top layer, the MS is connected to the three components. The first one is the PRM, which is basically for the physical resource monitoring, and the VRM is basically for the virtual resource management. And at the next one, which is for the system application monitoring, is the part which is related to SAM. So this is how we can have a monitoring system which is connected through three part, and we can have a similar kind of architectures. Then these particular architectures could have a lot of utilities, and architecture of complete medical cloud is being shown. So this is how they have seen the utility of this particular architecture of edge-based cloud for Internet of Medical Things. And in this particular case, at the bottom part, the micro data centers are being shown, and these particular micro data centers uh, are further collecting the information through the patients. As for example, I took an example of RFID could be the one of the way to identify the signals, and through this is being finally communicated through the network devices and being put at the cloud data center. So at the left side, we can say the one layer could be the terminal layer. Then we have the edge nodes, and the edge nodes can apply few filters or AI based filters. So when there is something which is unusual, that can be reported to the patient's caretakers, and at the same time that could also be reported to the healthcare professionals. So this kind of infrastructure has a lot of utilities, and this could provide a complete architecture of Internet of Medical Things. So I thought just let's have this case study as part of our discussion, uh, because we have also seen and we have also discussed a lot of points in context to the utility of machine learning models, specifically in context to the cloud. I think I can skip it. Yes, but these are few points which I thought if we are talking about this technology, what could be the research challenges? So these are few research challenges because still in India, if we look at the communication network, we are struggling with the data rate. So the integration of the 5G technologies with the edge computing could have a significant impact on applying these edge computing technology during these infrastructures. Still, the people are trying to resolve these issues. Another could be the edge cloud computing enable IOMT systems, where the focusing on edge device security and the privacy, because controlling these edge devices data is very challenging. So there is need to look at what could be the possible threats and how these threats could be handled. So I think this could be another challenge where that has to be taken care. So I would suggest that this Internet of Medical Things have a lot of possibilities where it would be using these machine learning models, and these machine learning models would be integrated with the cloud. So finally, I would conclude with in 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 summary, I would say uh, the integration of cloud and ML is basically a complete paradigm shift as much as the advancement in technologies is concerned. But at the same time, we have also seen there are a lot of advantages, but still there are a lot of challenges as well. So we have to see and try to overcome these challenges. And as already there are a lot of success stories, I've also discussed more than 14, 15 companies with the help of example how they are using the different services, and they are using the strength of machine learning models, and how they have integrated these machine learning models in the cloud itself. So we can say that, of course, there is no doubt, and there are a lot of case studies that applying the machine learning model may increase the productivity. It can scale up easily, so this can improve the scalability, and there are more possibilities of innovation, and guaranteeing that in future the cloud will become more intelligent, flexible, and this has a better resource for both individual and for the enterprises as well. So I would conclude this today talk with this particular slide, and these are the few references I just thought I should include while sharing this presentation. So these were the references. Thank you, everyone. Thanks a lot.